Proportional relationships, lesson 6 notes. A proportion. A proportion is an equation stating that two ratios are equal. At the bottom of the front page, divide that last section into 3 parts. I'm going to show you 3 ways to prove that something is proportional. So again, divided into 3 sections, and we're going to show 3 ways of proving that two ratios set equal to one another are actually proportional. Okay, so the first one, 180 over 3, and we're going to see if that is equal to 300 over 5. All right, so one way to determine if it's proportional is to simply divide. One way is to simply divide. Well, we already did 180 divided by 3 up above, which is 60. And 300 divided by 5, well, 30 divided by 5 is 6, so put a 0 at the end. That is also 60. Therefore, because these are equal to one another, these ratios are proportional. They are proportional. So again, one way of doing this is to simply divide. Another way, well, if I look at this, if I try to divide, I'm going to end up with a decimal number. So another way to determine if two ratios are actually equal or not is to reduce or simplify. If you put 9/12 into your calculator and reduce it, you would get 3/4. And again, if you put 21 over 28 into your calculator and reduce it, you would also get 3/4. Because the fractions are equal, these two ratios are proportional. Same thing. It's the same one as up here. So we already know it's proportional, but I'm going to show it to you anyway. Okay. The third way of determining if two ratios are proportional or not is to use cross multiplication. So we're going to cross multiply. I know that some of you like to prefer to call this the butterfly method. So cross multiply, I know you guys like to say butterfly method, which means that I'm going to take 9 times 28 and 12 times 21. Well, 9 times 28 is 252. And if you put 12 times 21 into your calculator, again, you would get 252. We already know they're proportional because we did it over here in the middle. But again, cross multiplication is another way to show that two ratios are in fact equal to one another, so therefore proportional. Now, the way we're going to do it the most is most likely going to be dividing. We're going to use division the most. Because again, a lot of times we want it to be a unit rate, therefore we want a 1 on the bottom, so we will divide. All right, you can flip your page to the very top of the front page on the back. So flip it to the back of the front page, go to the very top, and that's where it says, when two ratios are equal, they have a proportional relationship. When two ratios are equal, they have a proportional relationship. Go ahead and fill in those blanks. After you fill in the blank, write down this definition down here for rate of change. Okay, so again, when two ratios are equal, they have a proportional relationship. Where does that sound familiar? Well, that's the name of our notes. So right now I'm telling you that every single problem we're going to do here, everything has a proportional relationship. So we're going to use that for the entire set of notes. If you have any questions on proportions, let me know.